Okay, the PowerPoint I'm about to go through has to do with this particular article I've uploaded to the Canvas shell, so please read this first before going through the PowerPoint. Okay, risk ratios, also known as relative risk, versus odds ratios. These are measures of association which measure the strength of the relationship between an exposure and a disease. These two terms are interchangeable, risk ratio and relative risk, and then also odds ratios. So risk ratio, also known as relative risk, compares the probability of an event occurring to all possible events considered in a study, and it answers how much more likely. And this is an example of a 2-by-2 contingency table because we have two outcomes by two possible exposures. Okay, so to calculate the risk associated with an exposure, we must compare the risk incidence among the exposed to those who have not been exposed. So we have ratio of risk, the disease risk or incidence in the exposed, which is known as A divided by A plus B, divided by the disease risk, which is the incidence in non-exposed, so C divided by C plus D. So let's put in numbers. We have 490 and 25, 43 and 660. To find the disease risk, the incidence in the exposed, we do A over A plus B. So that's 490 divided by 490 plus 25, which is 0.95. And then we do the same for the denominator. We say 43 divided by 43 plus 660, and we get 0.06. When we divide that out, we get 0.95 divided by 0.06, and we get 15.8. The interpretation, how strong is the association? If the relative risk is equal to 1, the incidence in the exposed is equal to the incidence in the non-exposed. So there's no association and no increased risk. If the relative risk is greater than 1, the incidence in the exposed is greater than the incidence in the non-exposed, and there's an increased risk or a positive association. If it's less than 1, the incidence in the exposed is less than the incidence in the non-exposed, and there's a decrease or protective effect and a negative association. Cohort studies are relative risk only. If the population is small and well defined, such as 100 people who have attended a party and all are being surveyed for exposure to food poisoning and outcome, illness, no illness, so exposure to the food poisoning and whether they got sick or whether they didn't get sick, you have a cohort study, and therefore you can use risk ratios or relative risk. In case control studies, we can't calculate the incidence in case control studies, therefore relative risk cannot be reported in case control studies. Why? If we're looking at people under 21 with cancer, and we have 300 cases with cancer and 300 cases without cancer, that is just how we set up our study. Not necessarily because there's 50% of people under 21 have cancer in the population. We have cases and we have controls, and so we use odds ratios. Odds versus probabilities. The probability is the same as the relative risk. The probability of disease or no disease divided by all possible outcomes. So the odds is the probability of the outcome divided by the probability of the other outcome. So the odds is the probability divided by 1 minus probability. For example, if I have 60% probability that I will win a game, the odds for that is 60 divided by not 60, so 40, or 1.5 odds for winning. So odds versus probability. Relative risk is the probability that an exposed person gets the disease divided by the probability that an unexposed person gets disease. Odds is the odds that a case was exposed divided by the odds that a control was exposed. So how do we calculate the odds ratio? The proportion of people experiencing an event divided by the proportion of people not experiencing that event. So A divided by C is the odds that a case was exposed divided by B divided by D, the odds that a control was exposed. We can also just do the cross multiplication. A times D divided by C times B. Let's look at the odds ratio for ligation. We have 18 who experienced death with that type of therapy. We had 46 who experienced survival. Sclerotherapy, we had 29 who experienced death with that therapy and 36 who experienced survival with that therapy. If we just cross multiply, we can do 18 divided by 29 over 46 divided by 6, or we can cross multiply 18 times 36 divided by 29 times 46, we get 648 divided by 1,334, and we get 0.49. So how strong is the association? If the odds ratio is equal to 1, exposure is not associated with the disease. If the odds ratio is greater than 1, exposure is positively associated with the disease. If the odds ratio is less than 1, exposure is negatively associated with the disease. So for these data, ligation has a protective effect because it's less than 1. It is better to receive ligation as therapy than sclerotherapy. Odds ratios can be used with cohort or case control studies. Risk ratios or relative risk cannot be used with case control studies. They are similar when the outcome of interest is rare. Remember risk ratios. If the population is small and well defined, for example, 120 people attended a dinner and all 120 are being surveyed for salmonella, you have a cohort study. Participants are grouped according to their exposure to a factor, bad chicken, and disease status is evaluated. Therefore, you can use relative risk. The outbreak is in a community that is not well defined. For example, hepatitis outbreak in a city that has people traveling in and out. You will not be able to survey everyone with possible exposures. Therefore, you will have to compare cases to controls and will have to use odds ratios.